It's Mr. Benson here again on behalf of the Year 9 team with a video on the surface area of cylinders. Important stuff. So our topic, surface area of cylinders, that's 12.6 in the text. So we're looking at finding the surface area of cylinders by applying formulae that you should already be familiar with for the circumference and area of circles. And here are some exercises you can attempt. Okay, so what do we mean by cylinders? Again, cylinders are solid objects with circular ends, one curved side and a uniform cross-section. Now you might recall that I mentioned previously that when we're thinking about cylinders in terms of calculating the surface area, they do have quite a lot in common with right prisms. But the reason they aren't prisms is that they've got a curved side. So prisms always have flat sides. So if we think about our rectangular prism over here, let's say that we're thinking about this as the end of our prism, then all the other sides are flat surfaces. And the same with our hexagonal prism here. We've got the hexagonal ends, and these sides, which all have the shape of rectangles, are all flat. But what they do have in common is that they've got that right angle at the corner of the prism. So you can see we've got a right angle on our square prism, our rectangular prism there. We've got the right angle that forms on our hexagonal prism, and we also have a right angle between, if you think about the radius, say, of our circular end, that will always form a right angle with the side. So there's a similarity there. So even though they are not prisms, it means that we can actually calculate things in similar ways. So finding the surface area of a cylinder, what we can see is that we've got two circular ends, and if we draw the net of what the cylinder would look like, that becomes nice and obvious. And then where it becomes similar to our calculations with right prisms is that the curved surface of the cylinder here, when we flatten that out in a net, turns into a rectangular shape here, and so it's very much the same as what we could see with the right prisms. The difference is that the width of this rectangle here is given by the circumference of the circle, whereas with the right prisms it was just adding up the perimeter of the end shapes. So what this means when we're thinking about area, well, we've just got to apply our area formulae. So the area of a circle is just going to be pi r squared. Now we've got one of these at the other end as well, so we're going to have pi r squared at the other end. And in the rectangle here, well, the area of a rectangle is just the base times the height, so it's going to be 2 pi r h. So these are the areas of the three different parts, so we can then just add those together to get our total surface area. So here's our formula written in just one simple kind of equation. So the surface area of a prism is 2 pi r squared. So remember that we had two ends, each with an area of pi r squared. So 2 pi r squared is the ends, and then plus 2 pi r h is the area of the side. Now you've just got to be careful with this one, that this only works for the total surface area of a cylinder where we're counting both ends and the sides, and we're not doing anything strange to the cylinder. You might have to apply the formula slightly differently in other situations. So a simple example, find the surface area of the cylinder below. So when you are looking at these questions, be careful with units, because they might be mixed and you need to use the same unit. And it also depends a little bit on what the question asks. So with this one here, we've got a radius of 2 meters, and we've got a height of 3 meters. Now, if a question doesn't tell you the units that it wants the answer to be in, then follow the units that were in the question. So in this case, we're working in meters, so our area should be in meters squared. So if we just go with our formula, so our surface area is just going to be 2 pi squared plus 2 pi RH. So that's the formula for a standard cylinder that we've just seen before. So all we've got to be careful to do here is substitute correctly. So 2 pi 2 squared plus 2 pi 2 times 3. And do this on your calculator using the pi button so you get the most accurate answer. And we end up with 62, I'm just going to go 62.8 meters squared for that one. Here's a more challenging example. Now, these are the sorts of questions that you always find towards the end of each set of exercises. And we want you to practice these sorts of questions for a couple of reasons. Firstly, it's really important that you can interpret written questions correctly. And these questions also often contain more challenging maths that you need to be able to do as well. So often it's a case of applying the formulae that you've been learning, but in a slightly more complex context. So when you are thinking about questions like these, often there is information that we don't really care about that much in the question, and then there will be some information that's quite important. So when I'm looking through the question, so Mr. Benson lives in a concrete pipe in a vacant lot. Now, that's probably not very important information. The pipe sits on one end. Now that might be interesting when we're thinking about the area of the object. He wants to spruce it up a bit and wants to paint all the exposed concrete. Again, probably not that important. But then we get to a question. So what area, so that's what we're thinking about, will he need to cover? And we're given a unit. So those are important bits of information. And the pipe is 5 centimeters thick. Now, when you get a number in a question, it's almost always important. It's at least something that you need to think about carefully. It's unusual in tests and exams and stuff like that you get numbers that are unimportant. Now we've also got the diagram to think about down here, so there's probably some things that we can learn from the diagram as well. So one of them that's worth thinking about is that we have the diameter of the pipe here given as 1 meter, which means that the radius of the pipe, which is going to be to the outside of the pipe, is going to be 0.5 meters. So that's something that we'll need to use in our formulae. We've got our height here at 1.8 meters, and the thickness is going to be telling us about the thickness of the pipe there itself. Now, when we're thinking about the area that we need to cover, we've really got to think about what the question is asking us. So if I've got a pipe that sits on one end, then if I'm going to paint the pipe, then I'm going to paint the outside, I'm going to paint the inside, and I'm also going to paint the top. And so I just need to think about the shapes that are involved and the formulae that I'm going to need. So let's start off with the top. Now the top is an annulus, is the name of that shape. So we've got a larger circle, which is pi r, and it's the outside radius squared, minus the area of a smaller circle, which is pi r inside squared. And so I'm just going to work through this question one shape at a time. You could do it all in one big expression if you wanted, and you'll still end up with the same result. So in this case, pi, now my outside radius is 0.5 meters squared minus, now because the thickness is 5 centimeters, you've got to be careful with your units here. If we take 5 centimeters away from half a meter, we're going to end up with 0.45 of a meter. And carry out this calculation on your calculator where you use the pi button to give you the most sort of accurate version of pi. And what we're going to end up with here is I'm just going to round that to 2 decimal places, so 0.15 meters squared for the top. Then what we've got to think about is our sides. So these are relatively easy, where our inside, I'll start off with, is going to be given by 2 pi r h. So it's going to be 2 pi 0.45 times 1.8, and that equals, again, I'll do that to 2 decimal places, 5.09 meters squared. Our outside, again, 2 pi h, so 2 times pi 0.5 times 1.8, and that equals, so this equals 5.65 meters squared. Apologies for almost falling off the page. And then all we've got to do to figure out our total surface area is to sum those values up, and we will have our answer. So that would be 5.65 plus 5.09 plus 0.15, and we would have a total of so a total surface area of 10.89 meters squared for Mr. Benson's concrete pipe. Okay, so in summary, what we need to think about is that the total surface area is given by the sum of the area of the ends and the curved side, given by this formula here. So surface area is 2 pi r squared, which is the ends, plus 2 pi r h, which is the curved side. Remember that you might get asked questions like the one I just worked through, which are about partial cylinders, or maybe only, where you're only looking at perhaps painting the top or certain sides or something like that. And what to do now? Again, attempt the exercises, check your answers regularly and do all that sort of stuff, and email your teachers if you are stuck.